In the 8:45 class today?
Yeah, you can join that today.
And have you started VDocs or are you going to? Because then I'm not going to understand anything.
I'll give you some idea about what we are going to start. Yes.
Okay, thank you. And when you resume the last classes, could you please tell me?
Sure.
Thank you. Allah Hafiz.
Okay, Hafiz. अच्छा चले this paper, ठीक है? This is to one. Starting with the first one. उससे क्या कि I think it's about inorganic. He's saying that inorganic group 2. So he's saying group 2 elements share common chemical properties. Calcium reacts in cold water more quickly than magnesium because more energy is required to remove the outer electrons in magnesium. This occurs even though calcium atoms have a greater nuclear charge. Explain why more energy is required to remove the outer electrons. So when you go down the group, the size of the atom becomes bigger. So you're just going to talk about 2 points. One is that atomic radii of calcium is greater, atomic radii, and also the number of shells. You've got more shielding. So you're going to comment on these two things. Shielding effect of calcium is greater compared to Mg. So which is why it is easier to remove electrons from calcium compared to Mg. Next one is 0.0001 moles of strontium reacts with an excess of cold water. When the reaction is complete, a colorless solution is seen. Construct the equation for the reaction of strontium with cold water. So down the group, the reactivity increases. So strontium reacts with water and it produces strontium hydroxide. It's very soluble. He said that there was a colorless solution forming and hydrogen gas is going to be released. You can write down the states as well. This is aqueous. Water is a liquid and strontium over here is a solid. So 0.0001 moles. And then he says 0.005 moles of calcium and 0.005 moles of strontium are added separately to beakers. Each beaker contains 100 cm³ of cold water. At the end of each reaction, a white solid and a colorless solution are seen in both beakers. Predict which element, calcium or strontium, produces the more alkaline solution. Explain your answer. So both of them, you're adding calcium to water and you're adding strontium to water. So calcium hydroxide would be formed and strontium hydroxide would be formed. Now, he's probably adding it in excess because he's saying that a white solid remains. But anyways, solubility of the hydroxides increases down the group. The top one, magnesium hydroxide, is insoluble, but when you go down the group, barium hydroxide is very soluble. So the solubility of hydroxide increases down the group. So you're going to talk about this being more soluble. So it ionizes more or dissociates more and produces more OH ions. So it produces more OH ions. Hence, this one is going to be more, it's going to be more alkaline. Okay, so remember this, that hydroxides, the solubility of hydroxides, it increases down the group. Achha, here you've got the next one which says, describe one observation when magnesium carbonate is added to excess dilute sulfuric acid. So you're going to have carbonate with acids. They produce salt, which is MgSO4 plus water plus carbon dioxide. So one very obvious observation is going to be that you're going to see bubbles of gas or effervescence. That is going to be one really obvious observation in this case. So then you've got the next one, which is Element X is the metal reacts with oxygen to form a black solid oxide. The oxidation state of X in the oxide is +2. So X reacts with oxygen. So this is the first reaction that's happening. And the formula of the oxide is going to be XO because X is +2. He already said that, and oxygen is -2. So to balance this out, this would be your equation. But anyways, the oxidation state, it says the oxidation state so the carbonate X is a green solid. It decomposes on heating to form the oxide and a colorless gas. So there's a carbonate that decomposes. So metal carbonates, they decompose to form a metal oxide and carbon dioxide. Now, if you remember from O levels, although you need not remember the colors, but a black metal oxide is copper oxide, and a green carbonate is copper carbonate. So most likely this is copper, but remember, transition metals are not part of your AS exam. So you wouldn't be asked anything about identifying the metal over here in this case. So it decomposes from the information given state to similarities, and one difference that metal X and its compounds have with group 2 metals and their compounds. Similarity is, the difference is group 2 metals and their compounds, or specifically their compounds, are white in color. So they're white in color. And now he's talking about the similarity. The similarity is that group 2 metals would also react in the same way. They have the same charge. So if they have the same charge, the formula of the carbonate or oxide is going to be exactly the same. And the other one is, the other similarity is that their carbonates also decompose to form carbon dioxide. Or in this case, they didn't ask you to identify the gas, but their carbonates also decompose to form an oxide and a gas. Write the formula of the oxide of X. We already did that, so that's done. Write an equation for the reaction of XCO3 when it is heated. So we did that as well. We've already done that as well. So moving to the next question, that's the first question. Now he's asking for magnesium silicide is a compound that's made by heating magnesium with sand. You're supposed to draw the dot and cross diagram to show the arrangement of outer electrons present in a formula of Mg2Si, assuming it's ionic compound. So Mg is 2 plus. So only the outer electrons. So the outer electrons would be, magnesium is 282, but 2 plus means it's going to have 8 electrons in its outer shell, and it will have a charge of +2. Silicon, on the other hand, is 284. It would gain 4 electrons. So it's going to have 4 electrons and it's going to gain 4 more electrons, and it's going to have a charge of -4, which is why you would need 2 mgs for this reaction. So next you have so construct the equation for the reaction. So you're going to construct that. It's going to be Mg plus, I think, Mg2Si, sorry. They've already given you everything. So it's Mg2Si. It's reacting with water. and silane gas is produced, which is SiH4, and magnesium hydroxide is produced, which is MgOH twice. So we need to balance this equation. There are two magnesiums, so you balance the magnesiums. The silicon are already balanced, and the hydrogens you just need to count them, which is, so solid Mg is added to water, silane gas SiH4 is produced, and the solution of magnesium hydroxide is produced. So the tricky part is balancing the hydrogens. So there are 6 of them, and 2 oxygens. Now that's one problem that you have over here, which is it's kind of hard to really balance the oxygens in this case. So what you need to do is, in this particular case, what you need to do is, it looks like a redox reaction. It's a redox reaction because silicon over here is -4. But silicon over here is going to be, it's not actually a redox reaction. The only problem is Mg2Si. I'm counting the H wrong. There are 4 of them. अच्छा नहीं ठीक है, it's easy to,
हो जाएगा ना.
बस ठीक है. I was counting the H incorrectly. As the next one, suggest with reference to structure and bonding why SiH4 is a gas at room temperature. So structure and bonding, it's a simple covalent molecule with weak van der Waals forces. It's a non-polar molecule, so you can be very specific about the intermolecular force. All the dipoles are going to get cancelled out in this case. So it's only going to have van der Waals forces, temporary dipole induced dipoles, and which is why, because they have weak van der Waals forces, the molecules can therefore move freely. So they can overcome the van der Waals forces. And they can move freely. Next one is the electronegativity table is given. CH and SiH bonds have weak dipoles. Use electronegative values in the table to show the polarity of the CH and the SiH bonds. So you have to show the polarity. So CH, if you look at C and H, C is more electronegative. So C has greater electronegativity, so it's going to be slight negative, and H is going to be slight positive. And it's going to be a very weak dipole. If you look at Si and H, then H is comparatively has more electronegativity. So H is the one that's going to be slight negative, and silicon is the one that's going to be slight positive. That's the next one. Explain why CH4 has no overall dipoles. Because its shape, you're going to talk about the shape of the molecule, that it is tetrahedral. Which is a symmetrical shape. So all the dipoles are going to get cancelled out. Like, even though there is a tiny dipole, but the dipoles will cancel out. So dipoles usually cancel out in symmetrical molecules, and the reason is, like, U was more electronegative, H was the one that was positive, but the overall attractive forces are going to get cancelled out in this particular molecule. Part E, SiH4 reacts in air without heating, but CH4 must be ignited before combustion occurs. So suggest with reference to bond energies from the data booklet why SiH4 reacts in air without heating. So it would be a lot easier to probably break bonds. I mean, you can open the data booklet for this. And if you have a look at the data booklet, you can, I mean, you have to quote the relevant bond energy values in this particular case. So CH is 410. So that's kind of on the higher side. SiH, if you look at SiH, that's 320. So the bond energy of SiH is lesser. So it's 320 kilojoules per mole. And CH is kind of a stronger bond, that's 410 kilojoules per mole. So you're going to write that it's got weaker bonds. This one, which are easier to break. That's it. Hence, it has lower activation and energy. Next one is silicon dioxide reacts with hot concentrated sodium hydroxide. Identify two products formed during the reaction. So SiO2 is slightly acidic. So it's going to react with NaOH and it would form silicates. This is also part of inorganic. It's going to form silicate, which is going to be Na2SiO3. And a water molecule is also going to be, it's going to be produced. So you must know which of your oxides are acidic and which ones are basic. I can open the inorganic notes. The sodium oxide, magnesium oxides are basic. I mean, it's written over here. So sodium oxide, magnesium oxide, or hydroxides, they're basic. Aluminum oxide is amphoteric. It can react with HCl. It can also react with NaOH. And SiO2 is weakly acidic. So you need hot concentrated NaOH. And then you have these acidic oxides, phosphorus oxides and sulfur oxides are strongly acidic. They can react with NaOH only with dilute NaOH as well. So they're capable of reacting with dilute NaOH as well. So remember which of your oxides in period 3 are acidic and which ones are basic and which ones are considered to be amphoteric. Going back to our past paper, describe the behavior during this reaction. So it's behaving as an acid. That's it. 1 mark. Next one is construct the equation for the second ionization energy of argon. So the first one is already gone. Gaseous. Remember, don't forget to write the state. You've got argon would turn into +2 ion, and it's going to lose 1 electron. Now the graph shows successive ionization energies of the elements argon. Complete the graph. Which prediction of the 8th and 9th energies of argon use across for each data point? So what's going to happen is argon has a complete out shell, 18 electrons. So it's got 2 electrons, and then it's got 8 and another 8. So what's going to happen is that the first 8 ionization energies are going to be low. I mean, the first 8 electrons would be easier to be, I mean, removing all these electrons, outer shells, they would be easier to remove. Removing the 9th and the 10th electron, but removing the 8th electron would also not be that difficult. But removing the 9th electron would be very difficult. So the graph is going to give you a big jump. So the first 8 ionization energies would be very similar. And the reason for that is, I mean, what's the reason for that? That they're being removed from the outer shell. So they're very far away from the nucleus. So they're very far away. You've got a large distance. They're also more shielded as well, because they're very far away, so they have more inner shells. But as soon as you try to remove the 9th electron, removing the 9th electron becomes all of a sudden difficult, because the first 8 electrons were removed from the outer shell. The 9th electron is being removed from an inner shell. So all of a sudden your shielding decreases, your distance decreases. So it all of a sudden becomes much harder to remove that electron. So you have this jump. So sketch the shape of the orbital that contains, the energy value required to remove the first electron from an atom of argon is circled on the graph. This one, the first one. Sketch the shape of the orbital. So for that, you need to know the electronic configuration of argon. You don't need to know the entire electronic configuration. What you just need to know is the outer shell electronic configuration, which is going to be 3s2 and 3p6. Group 8 is always going to have outer electronic configuration S2 and P6. So you're basically removing an electron from the first electron is being removed from the outermost subshell, which is a P. So you have to draw the shape of the P orbital. So you can draw two lobes. That's it. Okay, that's your P orbital. There's an electron that's going to be buzzing around negative charge in this particular space over here. So moving on. Here's part D. This is probably related to PV0 NRT. He's saying calculate the mass in grams of Cl2 formed. For this calculation, assume that chlorine behaves as an ideal gas. So you just have to use PV is equal to nRT. And all you have to do in this case is you need to, pressure must be in pascals. So that would be 404 into 10 to the power 3 pascals. Volume which is given should be in meter cube. Cm cube to meter cube is 10 to the power minus 6. N is moles. So I don't think you have moles given anywhere. They haven't given you moles. So you can find moles. R is 8.31. And the temperature must be in Kelvins, which should be 25, would be 25 plus 273, which would be 298. I mean, that's going to be 298 Kelvins. So you try and solve for N. So you have to be very careful. Five, इसका बताओ क्या आ रहा है? That's multiplied by 20 into 10 to the power minus 6. And that gives you 8.08 divided by 8.31. And then you divide by 298. So anyways, I'm getting
0.2.
कितना आ रहा है?
0.23.
पता नहीं मेरा 0.00326 मोल्स आ रहा है. इसका चेक करो क्या आ रहा है. कंफर्म कर लेते हैं. We can just open the 1 second. So for this one, what are we getting? I think yes, man. I think he was looking for PZ to be very specific. But anyways, what are we getting for this? 0.00326. Okay, that's what I'm getting. So you're getting 0.00 or 0.00 actually. So you're getting 0.003263 moles. And you have to multiply it by the MR, which is 71. And that gives you 0.232 grams. You can make sure to write your values up till 3 significant figures, because your original values are accurate up till 3 significant figures. Okay, the next part is you're given, calculate the number of moles of chlorine atoms in this sample of Cl2. So one Cl2 has how many atoms? It's got 2 atoms, right? I mean 2 atoms of Cl. So it's basically 1:2. So you double that. So if you double the moles, what would you get? Multiply that by 2. You should get 0.463. Exactly 0.463 moles. You get double these moles, which you got over here. Sorry, I doubled the wrong thing. I need to double these moles. Which is 0.00326 multiplied by 2. क्या बनता है? 0.00326 multiplied by 2. 0.00652 moles. And then he says, if you're unable to calculate, so you may find it, I mean, that's it, calculate the number of moles of chlorine atoms in the sample of. So one Cl2 has two Cl atoms. So basically the moles are going to be doubled. So number of chlorine atoms, and number means you have to give the number. So you have to multiply this by the Avogadro's constant. He's not asking for moles. He's asking for the actual number. So multiplied by the Avogadro's constant, which is 6.02 times 10 power 23. So if I do that, so multiplied by 6.02, E23, I get 3.93 into 10 raised power what? 21, I think. Then he says Cl2 does not, Vice clear?
Yes.
So then he says that Cl2 does not behave as an ideal gas under these conditions. Explain why Cl2 behaves even less ideally at very high pressures. So the thing is that gases stop behaving ideally at high pressures. Why is that? The reason is they stop compressing. Pressure is inversely proportional to volume. So the idea is that gases have large spaces between them. So when you keep on increasing pressure, the volume keeps on decreasing. But so ideal equation states that if you take the pressure to a very high value, the volume should almost go to zero. So it should almost go to zero. So you keep on increasing pressure and the volume should go to zero, right? But in reality, that is not what's going to happen. Gases will become incompressible at a certain point. At a certain point, if you keep on increasing pressure, the volume would continue to decrease, but up till a certain point. At a certain point, at a very high pressure, the particles would all be close together and they would become kind of incompressible. So that would, I mean, they would start behaving like a solid. They're not going to behave as a gas. So the thing is, why do particles behave even less ideally at gas? Because the volume of the particles is not negligible. Is not negligible at high pressures. And the gas eventually becomes incompressible. So its volume is not going to go to zero as suggested by the ideal gas equation. The other thing is what goes on at low temperatures. Now, low temperatures is the easy part. What happens at low temperatures is that it's not going to remain a gas. Like if you're talking about water, the intermolecular forces are going to be significant and the molecules will not be energetic enough to overcome those intermolecular forces. So what you're going to write is that the intermolecular forces are no longer going to be negligible because the molecules are not energetic enough to break them. So intermolecular forces are not negligible. So the gas might liquefy, it would stop behaving as a gas altogether. I mean, the perfect example is that of water. As a next question, clarifies, is this clear?
Yes.
As the next one is moving to, you have to give the systematic name of this. Remember, the highest precedence functional group, that's where you're going to count. So 3 carbon atoms, that's prop. And ene because there's a double bond and it's going to be 1 ene. You're going to call this 1, this is 2, and this is 3. So the chlorine is going to be on the third one. So it's going to be 3 chloro, prop 1 ene. And remember the precedence of the functional groups. Cl की कोई importance नहीं होती. ठीक है, double bond is more important than that. Predict the bond angle. So whenever carbon is bonded to 4 atoms, it's tetrahedral. It's going to look like this. And the angles are going to be 109.5. So A is 109.5. B, on the other hand, is 120 degrees. Whenever carbon is bonded to or making a double bond, it looks like a fan. Okay, that's trigonal. That's going to be trigonal planar. Next one, when Y reacts with cold dilute acidified magnate 7 ions, compound Z is produced. State the molecular formula of compound Z. So what is he doing? He's state the molecular formula of Z. I mean, that's a simple one. Remember, these three are carbon atoms. Okay, every node is a carbon atom, and you just, this one will have 2 hydrogens. This one will have 1 hydrogen. This one will have 2 hydrogens. Okay, so you can just add in the hydrogens. So how many carbons you've got? You've got 3 carbons. Oxygen is 2. There's only 1 Cl. अब बैठ के ना hydrogens count करो, कितने होंगे? 1 2 3 4 5 6 and 7. ठीक है, correct me if I'm wrong. So that's going to be 7 hydrogen. Next one is name the type of reaction occurring when Y is converted into Z. That is oxidation. Remember, alkenes undergo mild oxidation. तो कहीं पे भी alkene होगा ना, it's going to be mild oxidation. Double bond की जगह ना यहाँ पे OH add हो जाएंगे. So that is, I mean, the double bond was here and you got OH diols are produced. So this is clearly an oxidation reaction.
Sir, oxidation पे marks मिल जाएंगे?
Name the type.
Specific होगा.
Name the, नहीं लिख लो mild oxidation लिख लो, लेकिन it's just 1 mark. ठीक है, लेकिन ठीक है, mild oxidation is even better. ठीक है. So alcohols can be classified as primary, secondary, or tertiary. Identify with a tick the alcohol group present in Z. So, ये क्या है? This one, primary or secondary or tertiary?
Primary.
ठीक है, and this one is secondary because the carbon is bonded to 2 other carbon atoms. ठीक है, so that's secondary. So you've got 1 primary and 1 secondary and no tertiary alcohols. So then you've got 4 compounds. He's saying identify all the compounds A to D that contain a carbonyl group. So CHO is definitely an aldehyde and CO is an aldehyde. So it's A and B. This one is an alcohol, which this one is a carboxylic acid. So they are not carbonyl compounds. फिर क्या है कि A and D are reacted separately with reagents given in the table. Identify which of the compounds A to D react with the reagents given appropriate observation when a reaction occurs. So all of them are reacting. Okay? So the first one is tolerance. Remember, aldehydes are the ones that get oxidized by tolerance. So it's going to be B. The observation is going to be that tolerance gives you a black precipitate and silver mirror is formed over the solution. So a thin film of silver is formed over the solution. Remember ketones, I'm going to write down the oxidation. Primary alcohols, वो किसमें oxidize होते हैं? They get oxidized to aldehydes and aldehydes further get oxidized to what? Carboxylic acid. So secondary alcohols, they only get oxidized till ketones, that's it. And tertiary alcohols don't get oxidized. So aldehydes are the ones that can be oxidized by 3 things. One of them is K2Cr2O7 or KMNO4, your usual oxidizing agents. The other one is aldehyde, and the third one is a ketone. अच्छा, फिर iodoform test. किसका होता है iodoform test? Iodoform test is alkaline aqueous iodine. That is for 2 very specific structures. It's either methyl with a carbonyl group, and the rest is R, whatever the rest is, or it's, you've got a methyl with a C with an OH and an H, or baki rest of the molecule. So if any molecule has these 2 specific structures, in the iodoform test, the CH3 breaks off, turns it into a yellow precipitate of CHI3, which is triiodomethane, और जो बाकी part है ना carboxylic acid में change हो जाता है. So who has this? C does. I mean, C has this structure. I mean, look at C. It's CH3 next to what? CH and OH and another H. So it has this structure. Who else has this structure? That one. नहीं, हाँ ठीक है, A के पास है, ठीक है. It's got a CH3 right side पे, next to a serial bond O. So it's going to be AN C. इसके पास भी नहीं है, इसके पास भी नहीं है, ठीक है? So it's going to be AN C, and you're going to get a yellow precipitate. In both cases, what will happen is the CH3 will break off and it would form a yellow precipitate of CHI3. Up here, sodium metal, alcohol or carboxylic acids both react with it. Okay, so these two are going to react with sodium metal. So alcohols plus carboxylic acid, so C and D. And you're going to see bubbles of H2 gas or effervescence, because hydrogen gas is going to be produced. Even alcohols, they react slowly with sodium. And the H in the OH gets replaced by sodium ions. And the H gets displaced and H2 gas is produced. So you're going to see bubbles of gas getting produced. Explain the meaning of the term nucleophile and identify the species. First thing, nucleophile. Nucleophile is anything, it's a species, an atom or an ion that is attracted to what? Kya hoga? That is attracted to?
Positive carbocation.
Positive charge. It could be any type of positive charge. Okay? Anything that's attracted to positive charge. But there's another thing and is able to it's able to donate a pair of electrons. So anything that's attracted to positive charge and is able to donate a pair of electrons. In this case, nucleophilic addition with Cn-1 that acts as the nucleophile. When this reaction ka agar wo pura mechanism dekhe na, ethanol hai na. So the whole mechanism is, if I draw the whole mechanism, it's remember you have to learn this mechanism as well. CH3 serial bond O and H. The carbon is positive and the oxygen is, it's a polar bond. So you have a CN, which is a nucleophile coming from NaCN that gets attracted to the carbon, which is positive. And the electrons in the double bond get repelled. फिर क्या होता है? फिर ये होता है कि CH3 CN नीचे जुड़ जाता है. You've got an H, और वो top पे ना oxygen -1 हो जाता है with its electrons. Then the H+1 from HCN gets attracted to the O-1 at the top and bonds with it. So you get a this thing is called a cyanohydrin. Achha, name the type of isomerism that's shown over here. That's going to be optical. Because there's a chiral carbon atom H. It's got an OH. It's got a CH3 on one side. And it has a CN on one side. So iske do mirrored versions honge. And he's asking you to draw the three-dimensional diagram of the pair of isomers. So I'm going to draw a mirrored version of this. That is going to be the second isomer. Okay, remember, everything should be mirrored. Like if I draw it below this left-right switch on it, so the CN would be on the left, which is slightly to the right, and the CH3 is over here. So both of them are mirrored versions of each other. That should be it, I think. As I give the structure of the organic product of the reaction with dilute sulfuric acid. Now, remember, dilute sulfuric acid hydrolyzes CN. So what happens is, you've got CH3, you got CH, the OH is still there. The CN turns into a carboxylic acid. That's it. It's only the CN that turns into a carboxylic acid. Nitriles get hydrolyzed when you react them with dilute acids. So okay, let's almost done हो गया. हाँ ठीक है, सारा कर लिया. So ठीक है, Faiz, we're done with this paper. ठीक है.
Okay, Allah Hafiz.
So okay.